Hey, let's go see what Phil's doing. Hey, what you doing?
Oh, I'm working on the second book in the Kingdoms of Magic series. That one.
Tell me again why you haven't published the first book?
Let's see. That one?
Yeah.
Well, book one in the series takes place at the same time as the book I'm working on right now, and I might have to change it a little bit if something in the story of book two. In fact, book three and four are also simultaneous. I'm going to not publish all four until they're all four are done. In case they change things on things. Hey, you're filming.
I am.
Well, I can stop writing if we want to get started on the SV Lynx video.
Absolutely.
All right, let me get the tripod set up.
Let's start this video with an update on progress toward the building of our Performance Catamaran. The APL Santiago cargo ship, carrying our kit in a shipping container, arrived safely in Singapore a few days ago, so it finished crossing the Indian Ocean and made it down the Malacca Straits.
Next up, it will be crossing the China Sea on its way to Shanghai, China.
With the start of our construction of our catamaran starting so soon, we met with Schionning this week and went over the plan for the first phase of the build.
After our meeting, we had a clearer understanding of the initial build schedule, which looks like this.
Number one, when the shipping container arrives at our build site, we're going to load everything from the container that comes from Schionning into our empty one, putting the stuff that we need later in the back and organizing it all so the stuff we need right away is up towards the front. And that whole process of unloading will take us about 1 day.
Number two, we begin work on the boat.
At this stage, we'll assemble the first of 3 configurations of some wood platforms that we're going to create. This one will be configured in a big square so that we can start seaming the panels. These are built out of 2x6 16-foot long planks assembled in a grid. Then, we screw down the plywood panels on top. We will use this platform to joining the pieces that are longer than 28 feet using biscuits. ATL Composites makes panels that are 28 feet in length, but some of the boat panels are longer than that, like the ones that go down the sides of the hulls. So we have to join those pieces with one seam. However, for any sections that will end up longer than 40 feet, we'll join them later on since we need to keep them in a secured 40-foot shipping container. However, there aren't too many of these. The joining process will take us about 1 week. Number 3. We will lay out the major bulkheads flat so that we may begin fiberglassing strips across the high-load areas. We don't have to glass the entire panel since they're pre-laminated from the factory. However, we'll also need to core the foam out of the edges and then insert the fiberglass rope reinforcements. The process of preparing these bulkheads will take about 2 weeks. Number 4. Once all the bulkheads are fiberglassed and sanded, we'll move on to the next phase. We will now reconfigure our wood platform into a long 50-foot by 4-foot length. Then we will assemble the strong back that comes in our kit and put that on top of the platform. Then we'll attach the forms for the canoes, which are the bottoms of the hulls.
Getting these constructed and leveled properly will take us an estimated 3 days.
Once the forms are ready, one of our crew will start cutting these long 50-foot panels into 1.5 to 4-inch long strips using a circular saw with a straight edge on it to run along that long thing. There are quite a few of these strips, about 60 of them needed for each hull. 2 of our crew will take each of these long, thin strips and bend and twist them into place as necessary as they dry fit them onto the forms. Then they screw that strip down into the forms to keep them in place. Cutting these strips and mounting them will take about 1 man-hour each, but we have 1 person cutting while 2 crew members are doing the mounting, so each one will take about a half hour. That's 30 hours total for all 60 strips, so about 4 days.
Once all 60 strips are cut and attached, we start removing them one at a time and adding thickened epoxy between the edges as we glue the strips back in place to each other.
And once we've mixed all that epoxy and laid them up and screwed them down and then cleaned up the overrun on the epoxy on each one, It takes the 3 crew members doing that about 45 minutes per strip. So if we look at 60 strips, that's about 45 hours, so about 1 week.
Once the strips are all epoxied together, we'll sand them with our flexi sander to get them as smooth as possible.
And we'll check for any low spots and fill those in with epoxy and get it as smooth as we can. But that'll all take about 3 days to finish. When the facets from the thin flat strips are fairly rounded out, we will apply a thin layer of fairing compound over the top and then sand again. Then repeat that process 2 or 3 times until the hull is a nice rounded shape. This will be a slow process with lots of sanding, so we figure it will take us 2 weeks.
Now we create the stands for this hull that the boat will rest on the entire time it's being constructed.
And to make them perfectly match the shape of the canoe bottoms, we put down a layer of plastic across the canoe at the places where the major bulkheads will cross. Then we lay down some fiberglass to create a mold of that hull shape. Once cured, we remove the new forms and attach the piece of fiberglass to a box that we also constructed from scrap foam core panel sections, creating our 2 hull stands for this canoe. We plan to build in a gap in the middle of the bottom part so that we can fit a floor jack. This will be used when the boat is finished to raise the entire boat about a foot higher, using 4 4-ton floor jacks. That gives us the height we need to back a flatbed truck trailer under the bridge deck of SV Lynx. Then, we lower it down onto pads on the truck bed, using the 4 floor jacks.
Building these stands should take us about 2 days.
Once the 2 stands for this canoe have been created, we remove the canoe from the forms and set it on those stands in the cement blocks we poured earlier. That should take a large group of our crew less than 1 day.
We'll repeat that entire process to make the second canoe, though we use the same form since the canoe portion of the 2 hulls are identical. That adds about another 4 weeks and 3 days of construction.
At this point, we're ready to install the 2 major bulkheads that span across the 2 hulls, tying them together. At that point, SV Lynx will finally start to take on the shape of a catamaran. Tabbing those 2 panels should take us about 3 days each, and 1 day for celebrating, so 1 week all total.
That means Phase 1 has been completed, and if our estimates were correct, it'll have taken us about 4 months to complete.
Yeah, and at that point, we'll finish that Phase 1, and that will be about mid-July. So at this point, we're going to wait and talk about Phase 2 when we get closer to that moment.
So that's the plan for getting started on the build of SV Lynx.
Since our shipping container is arriving in Long Beach in about 4 weeks, we thought that this would be a good time to talk about one of the mechanisms coming in that shipment. We're talking about our kick-up rudder system, which is part of the boat's steering system.
Let's take a brief look at that system.
When you purchase a kit from Schionning, you're buying the shell of the boat. Simply put, that does not include anything made of metal or acrylic. The kit is comprised of the pre-cut foam panels, fiberglass, fairing compound, etc.
But in our case, not the epoxy.
The Admiral's correct. If you recall, Schionning Design ran into shipping issues with the epoxy being deemed hazardous material by the shipping companies, right at the last moment as the container was about to be loaded. That caused delays in our shipment. In the future, I'm sure that Schionning is going to solve that issue, and so other people won't have that problem. But for us, it was an annoying issue that we had to deal with, which cost us 2 months of delays and a lot more money since we had to ship that epoxy separately as a hazardous material.
But let's get back to the metal parts we'll need for the boat.
Right. Those parts don't come in the kit, so you're going to have to source them locally through a machine shop. But Schionning will help you with the design on the parts. And in some cases, they will offer to have them manufactured in South Africa, and that is at a little bit better price and can come in your shipping container. So that's a good option when that is available. That is what happened with our kick-up rudder system. It was designed by the Schionning team, and then they offered to have it built for us in South Africa and shipped in the container. This mechanism is a separate cost from the kit, so you need to be aware of that when planning for the build of your boat.
Still, The price they could build it for in South Africa was far less than what it would have cost us to have it machined in the USA, so we agreed to have them build the kick-up rudder system and send it in the container.
Right. And here's the mechanism that they designed and built for us. As you can see, here, the top of the rudder shaft is attached to this U-shaped piece, which allows the rudder to pivot on this pin as the rudder kicks up.
Let's talk about why we need our rudders to pivot up rather than just have them fixed mount like many catamarans.
It begins with the fact that we're a performance catamaran and we have dagger boards instead of mini keels. We wanted dagger boards because they can add up to 2 knots of speed at certain points of sail. They also allow us to point higher into the wind, and when needed, we can raise them and our boat will have a shallower draft of about only 2 feet.
However, there is a downside as well.
That's true. Everything that you have to make a choice on involves a compromise. In this case, when we beach our boat, we won't have mini keels to rest on. When we beach SV Lynx, we'll have her dagger boards raised, and she will be sitting on the bottom of her hulls.
Structurally, this is fine since Schionning designed the Solitaire 1490 to be beached on its hulls, and since we kept the original design of the hulls the same, only lengthening them slightly, the Solitaire 1520 is also capable of being beached on the hulls.
And Schionning assured us that their hulls are over-engineered for beaching the boat. But I decided to customize it even a little further, and so we're adding basalt skins to the bottoms of the hulls to add some additional strength. In fact, by putting the basalt in there, we're about 15% stronger and 20% greater resistance to impacts. So that is just something we chose to do at our own cost, and it'll make our boat stronger for when we beach the boat and land on, say, a small pebble, and so it won't dent the hull.
But since we are landing on the hulls, no matter how strong they may be, we have another issue.
Yep. As you can see here, the rudders will project down to the point where they would land on the ground while you're beached. With all the weight of the boat coming down on them, the rudder shafts would likely bend. Therefore, since we have dagger boards, and we want to beach the boat, we must have rudders that can be rotated up and out of the way, like this. That's the primary reason for these kick-up rudders, but it's not the only advantage. If we happen to hit something while sailing, the rudders will release rather than break and kick up, hopefully allowing the obstruction we hit to pass on through without major damage to the steering system.
We'll get back to that feature in a moment. Those big boxes are part of the kick-up rudder system, and by moving that up with the rudder as it rotates, it creates a gap in the sugar scoop for the rudder to pass through.
Now let's get back to the mechanism that's coming in the kit for our kick-up rudders. This red section on top is removable. That piece allows you to attach a tiller for hand steering. When removed, this fitting has a cap at deck level. But if you lose your steering system somehow, you may remove the cap and attach the emergency tiller to the top of the kick-up rudder steering system and use the tiller manually to steer the boat until you can get to a place to fix the normal steering system. There's also a tiller on the other side of the boat as well.
Now let's talk about the automatic kick-up system and if, or more likely, when we hit an obstruction, be that a reef or a floating object.
There are various traditional ways of making these kick-up rudder systems, but we've decided not necessarily to go with one of those. The most common is to have a piece of wood that sits over the top of the rudder box and is attached to the deck. This piece of wood is supposed to snap off if enough force is put on it from below as the rudder hits something and the box tries to pivot upwards.
However, we hate the idea of having a stick of wood sitting on our deck, creating a tripping hazard or just something we might step on if we're not careful.
We also don't like that those pieces of wood take an unknown amount of force to break. As the wood rots, it will also change over time, and if you do break one, you'll have to replace it with a new piece of wood, one that will likely have a new amount of force needed to break. That's all not very scientific, or in our opinion, reliable.
So, we decided to design a new system that we think is much better. First of all, we're embedding the mechanism we designed below the deck level of the sugar scoop so that there will be nothing to trip over or step on.
Secondly, we are 3D printing this mechanism from nylon and carbon fiber so there's nothing to rot or rust. Thirdly, the release arms are designed to be replaceable and can be printed in different strengths until we dial in the exact amount of pressure we want for it not to release while in normal sailing, yet release every time in a known strength when there is an impact.
We can take several of these arms, which have different strengths, and test them while sailing until we find one that is strong enough not to release when normal forces like going about or turning the rudder when underway take place, but ones that will release if the rudder hits something.
As you see here, there's a rod that goes through the end of the rudder box and projects out about an inch on the other side. That rod will push down on the tops of the angled sections right here, and these two short arms will then spread apart, allowing the rod to drop down between them. Now, if the rudder is struck, the rod will try to move upwards, but will only manage to spread apart the arms if the force is strong enough to bend the arms apart. Once that happens, the rudder will rotate upwards without hindrance. It is also designed so that we can easily change out the arms by lifting these release levers and slide the arms out of the device to replace them with weaker or stronger versions until we find the one that works perfectly. The arms are made of a flexible nylon, while the rest of the 3D printed mechanism is made from onyx and carbon fiber. Here's an example of two 3D printed parts of those two materials working together in a snap system, similar to what I will use in SV Lynx's kick-up rudder mechanisms.
We would also like to note that we are not currently sponsored by Markforged, though we would love to get them on board. We're telling you about their printer because we like the quality and strength of the Markforged parts that we print on their machines.
And we're going to use a Markforged Mark II 3D printer to print these release mechanisms. Since it can print both onyx, which is a nylon material with chopped carbon fiber in it, and we can add continuous fiber to that material if desired. We can also print with a material called nylon white, which is flexible. Using the Markforged Eiger software, we can even pre-test the strength of the final part inside their software using the new simulation system. That simulation software saves us a lot of wasted time and the cost of generating test prints, since we can just dial in the forces and it will show us how strong the part is before we print.
John Savage, the owner of Engitype, is a longtime friend of ours who has kindly offered to sponsor the build of SV Lynx. John is allowing us to use one of Engitype's Mark II 3D printers while we construct SV Lynx. Engitype is also covering all our material costs to 3D print our lithium batteries and the solar arch supports, so we really appreciate John and his company's sponsorship.
And if you're on the west coast of the United States, well, that's what the area that they cover. So if you're interested in these 3D printers, you could send me an email and I'll put you in contact with John, or you can just look up the Engitype website, which I'll put a link down here, and you can go through it that way. But support him if you are in need of a 3D printer, because we really appreciate that he's helping us.
So you can see how useful having a Markforged printer is for working on a boat. In fact, if I had one of these Mark II printers on board when we set sail, it could be a real lifesaver.
Great. Here, I'll tell you what. Let me show you that Mark II and see what it looks like. You can see that this Mark II 3D printer is about the size of a sewing machine, so it wouldn't take up too much room on board. And we could print many different kinds of parts that we might need while we're away from a chandlery. For example, if we snap a pin or break a bracket that we don't have as a spare part, we could print that part using continuous fiber and make it very strong. So having a 3D printer like the Mark II on board could be a real safety device, since we would have our own little manufacturing plant in a box.
Now, let's get back to the kick-up rudders. The other nice thing about this design is that after the rudder kicks up, it doesn't break anything. If you hit something after it rotates up, the weight of the rudder box coming back down might even snap it right back into place.
And even if it doesn't, one of our crew can just walk back there and just push down with their foot and it'll snap it right back into place. There's no wooden dowels that broke that you have to switch out to a new one. You're just ready with the steering working right away. It's also easy to manually raise the rudders. All you need to do there is flip open these two doors, one on each side, and slide back the pairs of arms off the rod. Then you can manually raise the rudder box and prop it up. When you're ready to go, just drop it back down, slide those arms back over the rod, and close the hatches, and you're ready to go.
Let's take a quick look at the rest of the steering system.
The ship's wheel is mounted at the top, up here. Attached to the wheel hub is a 5/8" chain loop that goes down to this first pulley. That leads over to this second pulley, which turns a shaft that connects to the steering bar. These blue boxes you see here are the bearings to make the metal tube slide nicely. This steering bar angles down over here to connect down to the rudder mechanism by this tie bar. There will be a hatch above that so that we can access the mechanism in case it needs service at any time. So that's our kick-up rudder and steering system for SV Lynx. The entire kick-up rudder system has already been manufactured in South Africa and will be arriving in our shipping container, though we still need to have the steering and arm manufactured locally. The steering wheel, hub, and pulleys are all coming from our sponsor, Goyu, who make wonderful boat gear. And we're obtaining a lot of what we're adding to SV Lynx from their company. So you'll hear us talk about their products in some of our upcoming videos.
Next week, we hope to get out of the shop and away from computers and get to the ocean for our first sea trials of our electric tender outboard system.
And once we're out on the water, we get to check our E18's range and how much battery power we have in those 24-volt, 230 amp hour batteries that we put in series to get to 48 volts for the E18.
These batteries won't be in their final boxes. Those are being custom made by a friend of ours with a machine shop, but they'll be good enough to test out the motor and range of Traveler, our tender.
And we'll also get to switch out to the ePropulsion Spirit 1.0 Evo, and we'll check its range and find out how long the batteries last and such at different speeds. So that'll be fun to test as well.
So we'll see you out on the water next week.
See you there. Well, we hope you enjoyed this week's episode about our Phase 1 build plans, because the boat is coming in less than a month now. So we're getting ready to get started on that. And of course, us going over our steering system for the boat and the kick-up rudders. We're trying to be as informative and open about how we built this boat. And we want to show you every step of the way as much as possible.
So if you like our content, please like and subscribe and click on the bell icon to be notified of our next video.
And if you don't like it, well, we'll keep trying to do better. All right, well, we'll see you next week. And one more thing. We really love to thank our patrons and everyone who watches. So thanks again. Here's all the names that we have of the people. And there's a couple new ones on there this week. So again, thank you so much for becoming patrons, and we really appreciate you. We'll see you next week when we're going to go out on the water and test out the electric motors, both of them. See you then.
Bye.
Bye.